Moving on to the next section of aqueous solutions notes. This is where we start looking at some of the mathematics involved in actually doing calculations with some different kinds of solutions. So the targets that we're looking at today are calculate the molarity and describe how to prepare a solution of a given molarity. The idea behind molarity is really pretty simple. Molarity is symbolized with capital M. So if you see something like 0.7 molar of a solution, that means the number of moles per liter of solute in a given amount of solution, or liters of solution. Another way to think of molarity is the molar mass per the number of liters. So grams per formula weight, this would be like the grams divided by the molar mass, because that gives you moles, and then into liters. Molarity itself is pretty straightforward. We can do a lot of different things with it. So the other thing that's important here to recognize is this little bit of information right here, and that is the brackets. Anytime you see the little square brackets right there, that means concentration, and it also tells you that it's a solution and that its concentration is going to be expressed in molarity. So NaCl in brackets is 0.75 molar, means 0.75 moles of salt per 1 liter of total overall solution. Taking a look at exercise 13, we have sodium bicarbonate is used in baking powder formulations in fire extinguishers and in the manufacture of plastics and ceramics, among other things. Basically, baking soda is used in tons and tons of stuff. So it says if you have 26.3 grams of the compound, and the compound is sodium bicarbonate, that's NaHCO3, it's our bicarbonate ion, and you dissolve it in enough water to make 200 milliliters of solution, what is the molar concentration? So what we have to do in order to get molarity, that's moles per liter, so we have to translate this grams into moles and the overall milliliters into liters. So I'm going to go ahead and take my 26.3 grams of sodium bicarbonate, and then I'm going to use the molar mass to get moles. So the molar mass for that is 23 from the sodium, 1 from the hydrogen, 12.01 from the carbon, and 48 from the oxygen, 3 times 16. So 84.01 grams per mole of NaHCO3. Then I can divide 26.3 divided by 84.01, and that gives me 0.313 moles. Next I have to take my solution, and I have 200 milliliters. You can either move the decimal or use dimensional analysis. There are 1,000 milliliters in 1 liter, or you can move the decimal 3 places to the left. So 200 divided by 1,000 is 0.200 liters. And now you have your moles, and you have your liters, and you can divide the two of them. 0.313 moles per 0.200 liters, and you get 1.565. We only have 3 sig figs here, so I would probably round that to 1.57 molar sodium bicarbonate. For exercise 14, we have a similar situation. We have both lithium chloride and ammonium sulfate are strong electrolytes, dissociating completely into their constituent ions when dissolved in water. So they're both soluble. For each compound, write a balanced equation for the dissociation. All right, let's start there. Dissociation just means that we take the compound and we assume that it's placed into water. So that means that we're going to have lithium ions and chloride ions for the first one, and ammonium sulfate NH4 is a +1, sulfate's a -2, so we need 2 of them. So when we split it up, we have to label the ions appropriately. Okay, that was the first part. Next it says, assume enough of each has been dissolved so that the concentration of the lithium chloride is 1.0 molar and the ammonium sulfate concentration is 0.5 molar. Then state the molar concentrations of each ion and the total concentration of all the ions. All right, so first we have to look at each individual ion. If something is a strong electrolyte and dissociates completely, its overall 1 molar concentration is going to be split, but sort of remain the same. So if you had 1 mole of lithium chloride, then you have 1 mole of lithium ions, and you have 1 mole of chloride ions. So for the lithium ion, it's still 1 molar. For the chloride ion, it's still 1 molar. So that's the concentration here of lithium in the chloride. For the ammonium, it's 0.5 molar within the portion of the compound, but when it dissociates, each ammonium sulfate produces 2 ammoniums. So you actually have to double your concentration. So NH4 plus is 2 times 0.5 molar or 1.0 molar. The sulfate concentration, each ammonium sulfate only produces 1 sulfate, so then it is the same as the original concentration, 0.5 molar. The total overall concentration, if we assume all of these things are being placed into 1 liter of water, is to simply add them all up. Add up the concentration of lithium plus chloride plus ammonium plus sulfate, because now each individual ion is adding something to the solution. So that is 1 plus 1 plus 1 plus 0.5. So overall we have a 3.5 molar solution.